399,000. So they found that AC is cheaper than DC, much cheaper. Then AC wins, Tesla wins. That was the point that's making the standards in the US from DC converted to be AC. After that point, when he proved this practically, we can achieve this by 399,000. That was again in 1893. Then, in the same year, in 1893, Tesla did not stop. They didn't say, okay, I win and that's it. Let me do my own company and that's it. He's still doing more research. So what he did not stop only at AC alone. He invented something we call polyphase or three-phase AC. Polyphase or three-phase AC. He invented the three-phase AC generator. So the overall thing about three-phase AC, he doubled amounts of the power, triple amount of the power by doubling the cost. Almost something like that, 3 times the power by doubling the cost. Or even lower than doubling the cost. So also creating the three-phase will make it more better and better and better. So then definitely they say we no longer want the DC at all. Let's make the AC, everything at AC. So that's why, starting from that period, the overall standards in the whole world based on DC. Based on AC. Because again, this is because of the inventions of Nikola Tesla. Then everything is working well and we have step up voltages, step down voltages, and etc. So it looks like everything is good, right? AC wins and there's no problem. Okay, so then even after Edison and Tesla, there's still like AC and DC. Let's talk about now. Do you think like the world stops at that time? There was some updates happened. So there is something or a revolution in the technology that happens in the 20th century. What's this revolution in 20th century? Like the computers, we see that the computers and the communications as well, right? What's this revolution? What happens in the 20th century that makes this revolution? Inventing of what? The transistors, or like the semiconductor materials, right? Even now, we're still struggling with the semiconductor materials manufacturing as well. So the inventing of the transistors allow us to reduce the size of the computers from very big size to be smaller size, very smaller size, so it can be affordable. So in the past, the big computer was very big, because it has a vacuum tubes. Then we replaced this via transistors. The transistors, we reduced the size. Then by the time of the semiconductor materials invention and the more research, we reduced the size to be smaller, 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 and we can see computer right now in nano size. So the inventing of the semiconductors also make this revolution. So what happens? This revolution make it into the computers, make it into the communications. So we see radios, AM, FM, then we see satellites, then we start seeing the internet, the computers, mobile phones, smartphones, smart devices, then the robotics, etc. So it makes a revolution in everywhere. This not only happened on the communications and wireless area, it's also happened in the power system, into the electrical connection system. Okay, what did happen? Basically, there is the invention of a new science is called power electronics. I mean, we know electronics, but there's something happened later, it's called power electronics. So electronics comes because of the transistors, semiconductor materials. Then power electronics, using them in power. So we realized, actually, we can convert DC to AC, we can convert AC to DC, we can convert DC to DC, and AC to AC. That's the overall power electronics area. Okay, does this change something? this can change something. Like what? We realize using the power electronics, PE as power electronics, we can step up or step down DC voltage easy. Okay. We can step up or step down using the power electronics device after the inventing of the transistors and power electronics. Okay, how can this be helpful? Let's go to the challenges of DC. DC problems. It will go for few miles short distance because we cannot rise the voltage. Now we can rise the voltage or step up or step down the voltage easy, right? So that problem, this problem is no longer exists. So because we can do it after the inventing of power electronics, we can do it easy. Okay, so the losses will be less. We can transmit the power for longer distances. So the problems that we have in 1893, now in, I don't know, say like in 1960s, 1970s, they have been solved. Okay, so now, do we need to switch to DC? Or do you think AC is still more feasible? That was the challenge. So shall we remain on AC or go to DC? So we realized after doing several calculations, several assumptions, several negotiations, we realized that overall infrastructure right now based on DC, we spend billions on it. So let's keep it AC. We don't want to change it to DC. But we saw, or we realized sometimes when we use the DC can be cheaper. Like what? So we can say that when we use transmit the power for less than 1,000 miles, it's cheaper for us to use AC. When we have for longer than 1,000 miles, then let's use high voltage DC. That's the cheaper thing. Or in other words, high voltage DC, we used to call it as HVDC, HV as high voltage, HVDC. So we realized this is in the latest of 21st century. We realized that, okay, if we do HVDC, we can save some money. So that's, now we can say, okay, we can use DC, we can use AC. Then after that, the point is, okay, if I'm using HVDC, how can I convert this to AC? Using the power electronics. So if you need to transmit the power for longer than 1,000 miles, you have the power is AC, then you will convert AC to DC, then you will have HVDC, then after you come to the load side, you will convert DC to AC, then AC here will go to the load. Something like that. So we saw that the problem of whenever we need DC, we can use it by using the power electronics devices. Whenever we need AC, we can use the power electronics as well. Okay? Does this make sense? So the overall idea is about the costs. So whenever it's cheaper for us to use DC, we can use it. When it's cheaper for us to use AC, we can use it. And how can we convert this? By using the power electronics. AC to DC, DC to AC, which is this power electronics. This is power electronics device. And also the technology did not stop here. We also started the invention of like the batteries, the electronics, so all of them based on DC as well. Okay, so even let's back to HVDC. You can even go to Google and see HVDC. You will see some power lines in the world, but there are few power lines because most likely we don't make the power go for that large of distance, but you can see some power lines like between mid-south to mid-north in the US based on HVDC. You will see some I think in Russia, in China, some power lines like this. So it's called HVDC. Now based on also small voltage scales, we have computers, cell phones, and the other things. So cell phones based on DC. Computers like laptop, and the other things are based on DC. What we have here in the wall outlet based on AC. How can I do that? Basically, you will see, or your charger actually itself, here is the power line or the wall outlets, then you will connect this to your charger, then to go to your phone. Your charger has a small device that will convert AC to DC. It will convert AC to DC, then it will go to your phone or battery charger. So it can be in phone, it can be on electric vehicle chargers, it can be on laptop chargers, any electronic devices. So we are also using these devices to convert AC to DC. So we will not say, or we will stop saying war between DC and AC. And instead of fighting, AC will win, DC will win, let's use them whenever more convenient for us. Since we have the tool to convert AC to DC, DC to AC, then there is no need to say, let's make the system is based on DC, or let's make the overall system based on AC. We can use whenever we need. So if it is better, cheaper for us to use DC, let's use DC. Basically, just put the converter, then we can make this conversion. Then if it's better for us to use AC, let's use AC. Then again, and instead of fighting, let me support DC, let me support AC, now we can use them together whenever we want. Okay? So we will see this a lot. I mean, even some people try to make, we call it microgrid DC, which is making a standalone, making their a small project is under research and development. So overall home, overall maybe for example, company based in DC. But in my point of view, it's infeasible because some elements or some devices are based on AC, some devices are based on DC. Like the refrigerators, for example, the air condition based on AC, cell phone based on DC, microwave based on AC. So you will see multiple things, every element depending on each one, and everything, and something different. So again, now we can say DC and the AC together. DC and the AC together. So there is no need to say, let's support DC, let's support AC. Okay? Any question?